The Pythagorean theorem states that if we have a right triangle, then we can relate the sides to each other by the equation a squared plus b squared equals c squared, where a is one of the legs here, b is another one of the legs here, and c is the hypotenuse or the side across from the right angle. There are many proofs for this theorem, and we are going to look at one that involves a circle and a ratio using similar triangles. So before we begin with the proof, let's recall a relationship with similar triangles given this triangle here. And with this triangle, let's say we have a vertical altitude line that looks like this. So what we just did was create two similar triangles within this larger triangle, and the triangle on the left we can just call triangle 1, and the triangle on the right we can call triangle 2. And we're going to label a couple sides here. We're going to call the altitude, altitude. We're going to call the horizontal line in triangle 1 part 1. And we can see it only extends from the leftmost point to the bottom of that vertical altitude. And then we're going to call the horizontal line in the triangle on the right part 2. Okay, and we don't need the other lines labeled for this proportion we're about to set up. So since these are similar triangles, we can set up a ratio equals another ratio, and this proportion is going to be part 1 over the altitude equals the altitude over part 2. So we're going to have to keep that proportion in mind once we get towards the end of our proof here. Okay, so let's get into this proof. Suppose we have this circle, and this circle has a radius of length c. What we can do here is actually create a right triangle using this radius by drawing in a horizontal diameter through the center of the circle, as well as a vertical line completing the triangle. And that will look something like this, where we can call the length of this vertical length b, and we can call the length of the bottom, the horizontal bottom of this triangle, we can call this length a. Okay, now we're trying to prove that a squared plus b squared equals c squared. So there are several other points here of interest that we can label on the circle. We have this point all the way here to the left. Let's call that point F. We have this point up here at the top of the triangle. We'll call that point G. We have this point all the way to the right on the circle. We can call this point H. And we have the center of the circle we can call point K. So if you notice that F, G, and H actually create a triangle of their own, and it would be a right triangle that looks something like this. So let's extract the triangle FGH and take a look at it outside of the circle. And we have our triangle FGH. We can actually make this look like our triangle to the right that we originally drew and use that proportion for similar triangles to come up with a squared plus b squared equals c squared. So let's fill in the altitude here, and the other part of the triangle length c, which was the radius of the circle. And that will look something like this. So we know that the altitude is length b because that's what it is over here in our circle to the left. So that means we need two more things. We need part 1, which is this portion right here, and then we need part 2, which is the remaining horizontal portion to the right, which is right here. Okay, so the way that we're actually going to find this is based on the radius of the circle, which was c. So if we take a look back over here to the circle, we know that this length from F to K is a radius of length c. Similarly with the length from K to H, that will also give us a length of c, because that is also the radius of the circle. So if we want the length from F to the end of A, then that is going to be the radius c plus A. So that would correspond to this part over here. And now if we take a look at the part 2, the horizontal length part 2, which would be this portion right here, if we want to see what that is on our circle, that's going to be this portion right here from the right edge of A, or the bottom of the vertical B, all the way to the point H on the right side of the circle. So taking a look at what this is the radius c minus this length A inside of here. So on ours over here in the middle, that's going to be the radius c minus the base of that triangle A. So once we have those two lengths, we already know that our altitude here is b. Then that means we actually have enough information to fill in the proportion that we mentioned at the beginning of the proof. So it's part 1 over the altitude, so that's going to be c plus a over b equals the altitude b over part 2, which is c minus a. So what we're going to do here is we are going to cross multiply. When we cross multiply, we get b times b, so b squared equals c plus a times c minus a. And c plus a times c minus a, this is multiplying conjugates. What we are going to get is we are going to get c squared minus ac plus ac minus a squared after we FOIL that out. Since we are multiplying conjugates, we should expect those two middle terms to cancel off, which they do. And we end up with b squared equals c squared minus a squared. And all we have to do now is add a squared to both sides of the equation. And we get a squared plus b squared equals c squared. And that's how we know that we are done. That is the proof for the Pythagorean theorem using a circle and a proportion using similar triangles.